All right, so before we do examples, one thing I want to point out is the input and the output of our inverse sine function and all of our inverse trig functions. So whenever you have a trig function like sine of x, the thing we put inside of the function is an angle, right? We plug in these angles in radians or degrees. All right, from now on, we're just going straight to radians. So we can plug in angles and radians into our trig functions. So that means when we switch x and y and use our inverse function, we're plugging in numbers and we're getting back out angles. So the answer to our inverse trig functions will always be angles. All right, so let's talk about that. So here is our steps to finding the exact value of sine inverse or arc sine. All right, so basically we are saying inverse trig functions give us angles. So it's actually theta that we're finding. Theta is our sine inverse of x, and so we want to rewrite it in a way that makes sense to us. All right, so theta equals sine inverse of x means that sine theta is x. So you switch x and y to get the inverse, right? So you write it as theta equals, then you rewrite it using inverses, and then we have to make sure that our angle is between negative pi over 2 and positive pi over 2, because that's how we restricted our domain. And then we're going to use our unit circle to find the exact value on this interval from negative pi over 2 to positive pi over 2 that satisfies our equation. All right, that was a lot of words, but these problems are actually fairly short. Okay, so the first problem is sine inverse of 1/2. What is that? Well, first off, let's talk about what the question is actually asking us to find. It's saying that we want to find the angle, and our angle is given by sine inverse of 1/2. But we're really not used to looking at our functions like this, so let's rewrite it as its inverse. All right, so we can rewrite this as sine theta equals 1/2. And this should make a lot more sense to us. So we need to find places on our unit circle where sine theta is 1/2. We've done this before lots of times in our in-class worksheets. Okay, so let's find all the places on our unit circle where sine theta is 1/2. So sine theta is 1/2 here at pi over 6. It is also 1/2 at 5 pi over 6. So I'm going to write that down. All right, so remember, we're saying this angle that we were looking for could be pi over 6 or 5 pi over 6. We only need one answer, right, because our inverse trig functions should be functions, so we shouldn't have two answers. Only one of these is correct. All right, and so the way we figure it out is, well, we know the range of our sine inverse function. So I'll write it up here. The range, or the answer, of our sine inverse function is from negative pi over 2 to positive pi over 2. So our answer should, not a question, our answer should only be in this interval. Well, could you figure out what quadrants those are in? All right, so 0 to pi over 2, that's in quadrant 1. Let's write that down. How do we get from negative pi over 2 to 0? Well, that means we've counted backwards. 0 in the negative direction to negative pi over 2, which is at the same location as 3 pi over 2. This is also negative pi over 2. So that's going to be quadrant 4. All right, so that means our answer to this inverse sine function must only be in quadrant 1 and quadrant 4. So if we look at pi over 6 and 5 pi over 6, only one of these is in quadrant 1 or 4. Pi over 6 is in quadrant 1, 5 pi over 6 is in quadrant 2. That is not allowed. So our answer, sine inverse of pi over 2, sine inverse of 1/2 is pi over 6. Okay, let's do the same thing with question B. I'm actually going to make a line here so we don't get confused. All right, question B says sine inverse of a root 3 over 2, and that's what we're trying to find. So remember, we are trying to find an angle, and that angle is given by sine inverse of root 3 over 2. Right, and this is not the way we're used to thinking about our trig function, so we're going to rewrite this. This means the same thing as sine theta is root 3 over 2. So we're trying to find all of the angles on our unit circle where sine theta is root 3 over 2. So let's bring out our unit circle and find where sine is root 3 over 2. That is at pi over 3 and also 2 pi over 3. Only one of these is correct. It's going to be the one in either quadrant 1 or quadrant 4. All right, so this one is not in either one of those quadrants, so our answer is pi over 3. Okay. Okay, last one, sine inverse of negative 1/2. So again, we're trying to find the angle given by sine inverse of negative 1/2, which means we want to find all the places where sine theta is negative 1/2. So we bring out our unit circle. Where is sine theta equal to negative 1/2? Well, over here, 7 pi over 6 and 11 pi over 6. Okay, well, we know 7 pi over 6 is in the third quadrant is not where it should be. 11 pi over 6 is in the fourth quadrant. However, is 11 pi over 6 between negative pi over 2 and positive pi over 2? Should not be, right? 11 over 6 is about 1.8. That is much bigger than 1/2 pi. All right, so this also is not the answer. It is, however, coterminal to the answer. All right, so here we're at this location. That means we could have also just counted backwards pi over 6. All right, so we need to subtract 2 pi and we're going to get negative pi over 6 as our answer. So this is in the fourth quadrant. Sine of negative pi over 6 is negative 1/2. Also, this is between negative pi over 2 and positive pi over 2. All right, so the answer is negative pi over 6. Okay. All right, so that is how we are going to work all of our inverse trig function problems. All right, let's go on to cosine. It will be very similar. So let's look at the graph of cosine. It didn't quite leave us a lot of space, but I'm going to draw it down here with our usual points. All right, remember cosine goes 1, 0, negative 1, 0, 1, and reverse. So something like this. I'm not great at drawing cosines. So this is y equals cosine of x. And we want to talk about the inverse of our function. Well, question, does this pass the horizontal line test? No, it does not. So that means we're going to have to restrict our domain. So this does not pass horizontal line test. So we're going to have to restrict the domain. And so the only real rule that I've noticed is when we restrict it, we want to include the 0. So what's going to happen is we actually can only use between x equals 0 and x equals pi. Because in this interval is where we can pass the horizontal line test. Okay, and so we can figure out our domain and range, right? So the domain for cosine that we're using is between 0 and pi. That's going to be the range of our inverse, between 0 and pi. And then the range of cosine is going to be the domain of cosine inverse. So from -1 to +1. All right, and so we can talk about cosine inverse, or we can talk about arc cosine. They mean the same thing, and then I will show you how we can work these problems.